Students, have thought about the force? When we apply the force on a body, then we can change its shape. Okay, this is the cause by which you can change the direction of the body. You can change. This is the cause by which you can change the speed of the body. Okay, if a body is in motion, you can stop it. If a body is already stopped, that is in rest, you can start it in motion. So force is the external cause by which it is the cause, you can say it is the cause or external effect which can change the state of motion. Okay, that is, if it is already in motion, you can stop it, and if it is already in rest, you can bring it in motion. Shape, size, and direction of the body. Okay, so it can change. This is the force, and you must know its SI unit is Newton. SI unit is Newton, or which is also known as the kilogram meter per second square. Okay, this is the SI unit. So students, you know, first of all, what is the effect of the force on a body. For that, we'll discuss about the balanced and unbalanced force. Okay, balanced and unbalanced force. Suppose it is a body and you are applying the force on this body in this direction. Okay, so will it move? Will it move? Yes, it may be move, not, and sometimes it is not possible. How? Suppose when you are apply the force on it, then at that time there will be some more force will be in action. See its weight, downward direction, and the reaction of the normal, that is the from the surface, it will be in opposite direction. Reaction from the surface, it is in upward direction, and if the body is not moving up or down, then weight is always directly proportional to the normal reactionary force. And one more force, it is in always opposite direction, always in opposite direction, that is the frictional force. Frictional force, that is the force between the surfaces of the body, of the moving body, and the surface. Okay, that is the between two surfaces, so it will oppose the main applied force. So if these all forces are equal and opposite, that is R is balanced by the W, that is the weight, and the applied force is balanced by the frictional force, then these forces are known as the balanced force. These are known as the balanced force, because all forces are balancing to each other. It means if the resultant of all acting forces is 0, then the forces are called balanced forces, are called the balanced forces. Okay, so this is the balanced force. So in this case, body will not move, body will in equilibrium, or it is in stationary state. Okay, that is the balanced force. Now if we discuss about the unbalanced force, see what is the unbalanced force. Unbalanced force means if the resultant is not zero, then what will happen? Body will start moving. body will start moving. Suppose up to a certain limit, body will not move. But when you apply more force, suppose this value becomes more than the frictional force, in that case body will move in the direction of force, and it means you can say unbalanced forces causes the motion of the body. Body will move, body will come in motion only and only when the unbalanced force is there. So unbalanced force, in the same way you can write, if the resultant force, resultant of all acting forces is not zero. Okay, here it was zero. Then the forces are called unbalanced force. Unbalanced force. So here the resultant of all the forces is equal to zero, and here the resultant of all the forces not equal to zero. So in other words you can say unbalanced force. In other words you can say unbalanced force causes the motion. Okay, if all are balanced, then the body will not move, and if all the forces are not balanced, in that case it causes the motion of the body. Now once the body comes into motion, we have to follow some rules, and these laws were given by the Newtons. So we'll discuss 3 laws of the Newton. So one by one we'll discuss Newton's first law of motion. Newton's first law of motion. Okay, before knowing about this motion, this law, we should know about the inertia. Okay, only then we will be able to understand what is the Newton's first law. So see what is the inertia. Inertia means it is the inherent property. It is the inherent property of the body by virtue of which a body resists its change in position. It means, in other words you can say, if a body is in motion, it will be continue in motion, and if a body is in rest, it will be continue in rest, unless until you apply some force on it. Okay, suppose a stone which is in the ground, it will be continue in the ground. If you apply the force to lift it, only the body will move, or you can lift it. Similarly, if a body is in motion, suppose something is rolling through a slope, if you apply the force to stop it, it will be stopped, otherwise it will be continue in motion, it will be rolling. So this property of the body is called the inertia. Inertia is of 2 types. Okay, it is of 2 types. First is inertia of motion, and second is inertia of rest. Okay, in some book it is given inertia of direction also, but in your syllabus only 2 inertias are given: inertia of motion and inertia of rest. Inertia of motion means when a body is in motion, it will be continue in motion unless you apply some external force on the body. Okay, it will be continue in motion. So we can write the Definitions of the inertia of motion. A body will be in motion unless some external force applied on it. Okay, this is the inertia of motion. Okay, see the example. There are so many examples. Inertia of motion. You can read different examples. I'm taking the one of the most popular example. Suppose you are in a running bus. Okay, you are in a running bus and bus is moving. Suppose at any place it is stopped suddenly. So okay, bus is stopped suddenly. Then what will happen? You will fall downward direction. You will fall. Why? You can apply here the inertia of motion. Actually, what will happen when you are sitting in the bus? Your lower portion of the body will be in close contact with the surface of the bus, and your upper portion will also. So when the body, or you can say the bus stopped, then your lower portion, which is in contact with the surface of the bus, will also stop suddenly, but your upper portion will be continue in the motion. That's why you fall in forward direction. So there are so many examples you can read. Now it was the inertia of motion. Now the second type of the inertia of motion, that is the, you can say, inertia of rest. Okay, so now the second inertia of rest we'll discuss. Inertia of rest. It means if a body is in rest, it will be continue in rest unless some external force applied it. So a body will be in rest unless some external force applied on it. Okay, so this is the inertia of rest. Okay, inertia of rest. Example, the same example you can take, like suppose a bus, it is not moving, suppose, and it starts suddenly. Suppose it starts suddenly. Then if you are inside of the bus, then what will happen? You will fall. You will feel that you will be falling in backward direction. Okay, in backward direction. So why it happens? Because when the body, suppose this is the body, which is the position when the bus is not moving, and suppose the bus start moving. In that case, what will happen? The lower portion of the your body will start moving, but it will move in forward direction, in the direction of bus, but your upper portion will not move suddenly. It will not share this velocity. So in that case, you will feel that you are falling in backward direction. Okay, So this is the example of inertia of rest. So many examples you can see. So if we join these two, rest and motion, we can give one more law, that is which is known as the law of inertia. Okay, so law of inertia, which is also known, the same law is known as the Newton's first law of motion. Okay, Newton's first law of motion. So what is the law of inertia? If a body is in motion, it will be continue in motion, and if it is in rest, it will be continue in rest, unless some external force applied on it. Okay, this is the first law of motion, or which is also known as the law of inertia, or sometimes it is known as the Galileo's. Okay, Galileo's, like spelling, Galileo's law of inertia. Okay, it was given by the Galileo, and it is mentioned as a Newton's first law of motion also. Now come to the Newton's second law of motion. Newton's second law of motion. Dear friends, there are three basic laws which describes the motion of the body. First law, it is known as the law of inertia, and the second law, it is known as the law of momentum. Okay, law of momentum. So to discuss Newton's second law of motion, we should know what is the momentum. Okay, so see what is the momentum. Momentum denoted by the small p. It is always equal to the product of mass and the velocity. It is equal to the product of mass and the velocity. And remember students, it is a vector quantity. It is a vector quantity. Vector quantity means which depends on the direction, and its direction is always in the direction of the velocity. Okay, the direction of velocity will be the direction of the momentum also. And see what is this SI unit. SI unit, what will become? Kilogram, and this is the meter per second. So kilogram meter per second is the SI unit of the momentum. We will have one more unit of the momentum, and will be discussed in the next topic. Okay, so this is the Newton's second law of motion. Is it clear? So momentum, mass into velocity. So see what is the second law of motion. Second law of motion states that the rate of change of momentum. Okay, that is the, I can write like this, the rate of change of momentum is directly proportional to the force. Okay, see what is the, suppose the final velocity is v, and the initial velocity we consider, suppose it is the u. Okay, then the final momentum, what will be the final momentum? It is the mv, and the initial momentum, it is the mass into initial velocity. Okay, and rate means the dividing by the time. Okay, duration. So this is the rate of change of momentum. It is always directly proportional to the force applied on the body. In other words, you can say force directly proportional to m v minus u, okay, upon t. Is it clear? Is it clear? So it is correct also, because when you apply the force on the body, what will change? Its velocity, not its mass. You will not change the mass, you will change the velocity of the body. So we can write force directly proportional to mass into change in velocity upon t. And since we know v minus u upon t is equal to the acceleration of the body according to the definition of the acceleration, so we can write f directly proportional to the m into a. Is it clear? M into a. And or we can write f is equal to a proportionality constant k m a, and if we take m is equal to 1 kg, a is equal to 1 meter per second square, then in that, and the f is equal to 1 Newton, in that case k is equal to 1. So if we choose the SI units of the force, mass and acceleration in such a way that the k becomes 1, so we'll write here f is equal to m into a, because we consider in SI unit k is equal to 1. Okay, so it in SI unit k is equal to 1. So this is the alternative form of the second law of motion. Okay, so what is the second law of motion? The rate of change of momentum is always directly proportional to the force applied on the body. Or alternative statement, if F force applied on a body of mass m, then acceleration a is produced in that body. This is the second law of motion. Okay, so from here you can write the unit of the force. It is the kilogram meter per second square. So in the starting of this chapter we discussed the SI unit of the force. It is the Newton, which is also equal to the kilogram meter per second square. Now see its example. A very interesting example, most popular example I am taking here. If ball is thrown, or if a ball is catched by the fielder in the cricket ground, okay, then what will happen? The ball will be not stopped suddenly. The player will tend to move the ball downward direction, and then the ball will be stopped. Okay, like this. Suppose this is a ball, so it will be not stopped suddenly. Okay, so it is falling, so the player will stop slowly. Okay, and he lowers his hand downward direction. Okay, not suddenly. It will take some time to stop the ball. So that's why it happens. Why the player do this like this? Because you can see here, if the t is very small, then force will be very large. And if the force is very large, in that case the palm will be injured. Okay, the player may be injured in that case. So to stop the ball, player increases his time in stopping so that the force becomes less. If we increase the time, then force will be less. So this is the Newton's second law of motion. Now we'll discuss one more law, that is the Newton's third law, which is also known known as the law of action reaction. Law of action and reaction. Okay, again interesting law. There is always equal and opposite reaction. There is always equal and opposite reaction. Okay, reaction of every action. Okay, of every action. There is always equal and opposite reaction. Okay, it means if a body exerts a force on the second body, then second body will also exert the same force in opposite direction on the first body. Equal and opposite always. Okay, so this is known as the law of action and reaction. Different examples you can take in our daily life. We can walk only due to the this law. Means when we apply the force on the ground, then the ground will also exert a force on your feet and you will move in forward direction. Or in case of the rocket propulsion, so gases emitting from the rocket, it will exert a force in downward direction, and the force, and as a reaction the rocket moves in upward direction. Okay, or another example, suppose the gun. Okay, when you fire the gun, it recoils. Okay, suppose this is the gun and the bullet is moving in forward direction, then the bullet will also exert a force on the gun and you will feel a force in backward direction. So all these examples are the law of action and reaction. So you may read some more examples in your book. So I've given the basic ideas of the first three laws. In next video we'll discuss about the law of conservation of forces and some examples based on the law of conservation of the momentum. Thank you, students.